So we are live, I believe. Hello, good morning, good afternoon, my friends. Probably most of you, I don't know. Where are you connected from? So good morning, good afternoon. Today, the topic is to start to work on and hopefully to finish the PCB layout of the energy monitor with the INA2227 last week we worked on the schematic. I made a quick check before the show and I found out that there is missing terminal for V-bus connection. Generally there are two V-buses, V-bus 1 and V-bus 2, and there are only 4 terminals for the load, the connecting of the load, high side, low side, high side, low side for both channels, but there is no input for the V-bus. And let me open a new browser window with the datasheet of the IC. Here it is. And as I understand, the V-bus 1 and V-bus 2 can be completely independent because there are voltage sensing of both of them independently. Yes, channel 1, channel 2. We can imagine that there is like 2 similar devices inside of the IC sharing the logic and communication stuff. So we will add 2 terminals with V-bus and ground, the same terminals as these ones. These ones are my favorite. Those connectors, those terminals are not the cheapest ones, but I like them. You probably saw them on my other devices. I'm looking for them to show you. Here is one of my board, and this is the big one, not this one. We are going to use the 44 degrees one, the push-in ones. I don't know if you can see it. Probably yes. So let's start. Let's start with these 2 terminals, and my plan is to add some test descriptions because frankly, when I opened this project, I don't know, 15-30 minutes ago, I was a little bit confused because the week is quite a long time and I forgot all the details about this project. So I had to refresh my memory for that. So I think adding some small test description labels would be helpful for a future debugging, testing, anything. I don't think that we will need to debug extensively because the device is rather straightforward, but yeah, nobody knows. So right now I'm thinking about adding some ESD protection. The fact is that the maximal voltage of the V-bus is 48 volt. So when speaking about the ESD connection, there is missing diode protecting the VS voltage. So let's add it. I think D4. I can manually annotate the diode. And what about the inputs? the VBus inputs. Should we add a ESD protection on them? Probably yes, but what value? We can use 5 volt, 10 volt, 24, 30, 36, 48, or even slightly bigger, because the absolute maximum rating is, as we mentioned last time, a rather confusing value of 53 or something. It was mentioned in the application and implementation section. Here it is, 52.42. So what diode? I don't know. Sorry, it was my LinkedIn. We don't need it now. So yeah, I think I will not use the ESD connection here. We can place some TVS as a component placer. That can be a solution, like I call it Transil in my library. So let's say SMA 58, which has 68 volt breakdown, so it is too high. So let's open it just for the sake, but I would like to have the bi-directional one. This is the CA at the end of the name, of the part number. So when I take the SMA J30 and open the data sheet for it, yeah, as we say, 52 is the maximum breakdown voltage, the typical breakdown voltage. Yeah, this one looks like it can be used, but with some headroom, let's say, we can use the 45 J45 CA. That would be our device. Yeah, for the sake of clarity, I should add a new device, as we agreed, or as I said, 45 CA in my library, because this design, as well as other hardware design templates, will be shared as a hardware design template or many devices website. And I don't want to confuse you. I will use only components that are to be placed there. And yeah, my intention is not to confuse you. My intention is to help you design new devices. So yeah. Now I have to look for the JLC part number, because yeah, quite a long time ago I started adding the JLC PCB codes, ordering codes into my database, because I can say the majority of my customers want to order at JLC PCB in some phase of the design, either prototypes or a small series, and yeah, the JLC PCB codes, yeah, as we understand, help to streamline the manufacturing order, because yeah, it's a no-brainer. So here is our device, and I will mark it as non-placed, because as I said, when using any lower voltage, it would be useless. But as a component placer, it should be there. Yeah, I love symmetricity or symmetry, as you know, so something like this. And because I need to rework it significantly, I duplicate this entire micro block just like this. And as we said, short test descriptions. So this is high side load connection, as well as here. And the other one is a low side load connection, as well as here. It might be seen as a useless description, but as I said, when I opened the schematic today, I had to think about how I design it, how it should work, and yeah, any test description that is there can save time, either 1 second or minute. Every second counts. So we have ESD protection for all the, let's say, system signals. We have 4 mounting holes. We have pull-ups for I2C line. We have pull-up for alert line or alert open drain output. We have 4 configuration resistors for the addresses. We have input filtering for the shunt resistor sensing. We have 2 shunt resistors, 2 identical channels allowing connecting high side load or low side load, and 2 terminals connecting the V-bus and V-bus 1 and V-bus 2. Right now, yeah, you know me. I am obsessed with symmetry and alignment, and you can see that the shunt resistors are not aligned with the torrent cells, and I hate it. So I have to move them. See how beautiful it is when the components are aligned. The terminals are aligned. The resistors have the same distance, the same gap in between them, or the diodes. Yeah, that's my thing. Let me check comments. No comment. Okay. I hope we are live, but yeah, I think we are. So we have to annotate the schematic again because there are some new components for new components, and I was about to say that there are not just missing, but there are no LEDs on the board. Do we need them? What we can sense or we can signalize with the LED or signal with LED. We can signal alert output, which is not, I think, needed. We can mark the presence of the V-bus 1 and V-bus 2 voltage. But again, it's depending on the input voltage, so there should be an NMOS switch with some leading voltage divider with unknown ratio, because 48 volt needs a completely different ratio than the 5 volt need 5 volt V-bus. So I think it would only complicate the entire schematic. If you don't mind, I will not use any LED on this device. When speaking of debugging and testing, there are no test points. I strongly recommend to place as many test points as possible on each of your designs, because it makes significantly easier every debugging, because you can point your probe of your multimeter or oscilloscope to the test point instead of the path of the resistors or any other IC capacitors, etc. So I think we can place some test points, or we should place some test points. The device is about energy monitoring. So these components are the most critical. Do we need to sense the voltage on the shunt resistor? Probably yes. Do we need to sense the voltage on V-bus? Probably yes. Do we need to sense anything else? Yeah, we can want to sense the Vs voltage somewhere. Definitely, we can use the test point on the ground side. Okay, so V-bus1, V-bus2, ground, and Vs, and the shunt resistor as well on both sides. Okay, so plenty of test points. Let's get them there. So test point. I think the circular 1.27, which is a 50 mil diameter of the test point, will be fine for our purposes. And this will be one with VBus1 name. The second one just here. The ground one for about here, and now the shunt resistor test points. We have to be careful with the space because yeah, these two terminals are close together, and we don't want to yeah, KiCad doesn't allow us to overlap the symbols. Yeah, I'm wrong. Probably it allows, but it's definitely not a good habit. So we have to make a room for the reference designators. So I'm going to rearrange the test descriptions of the reference designators of the shunt resistors, because there will be the TPX, probably single digit, but I still don't know what is how we ended, what number what total number of test points we are going to use. So this is the high side channel 1, let's say A, and high side channel 1 B. Yes, okay. Now we can duplicate. Oh no, high side. It's a sense. I'm sorry, sense or shunt, whether shunt A, shunt B. This is our thing, because when we want to sense the voltage at the high side, we can use this test point and the VBus1, respectively this future test point and the VBus2. So we don't want to go crazy with the number of test points, but we want to be able to test and measure effectively the device. So VBus1, VBus2, okay. Shunt number 1 A, shunt number 1 B, shunt number 2 A, shunt number 2 B, okay, and ground is here, and it needs to be renamed to ground. Okay, now annotation. Okay, so I think we are good to go with the ERC. I strongly recommend always use the ERC as much as possible, as frequent as possible, no errors, no warnings. At least it confirms you that you are doing a good job, good progress of your schematic. And yeah, I don't say that I recommend to call the ERC check every other like hour or every other step of your schematic, or yeah, schematic progress. But at least before you switch the schematic to the PCB layout, like to update PCB layout from the schematic. Let's check the comments. No comment. No comment. It means that we can continue. So, as always, I will use the split screen mode. So split screen for the schematic and split screen for the PCB. And by hitting FH, we are going to update the PCB from schematic. I always recommend to check this list of changes, all the changes that are going to be applied, like from the current update step. No errors, no warnings, just the list of the steps that the updater is going to do. So here are our components. Okay. First things first, switch off the values and switch off the select screen. Now the schematic is not the schematic, the components are much clearer. There is air in between them and less crowded. Right now the redness is hidden, so we need this feature, so I switch it off, switch it on again. And now, as you know, I always start with the top left corner. Because we always need a starting point where to start with the component placement. And in my understanding of world, I always start from the top and from left, because I write from left to right and read from top to the bottom. It's natural. If you read from right to left, you can start with the top right corner or any corner you want. And I want to place this component 4.5 millimeter far from this corner, because it's value that perfectly fitting the shape of the mounting hole, because I will use the fillet option for the PCB shape, and 4.5 millimeters distance is the perfect distance for the fillet. I am talking too much today. I should work. We are 23 minutes in the show, and I only place one mounting hole. I don't know if we managed to finish the PCB layout today. I think we don't, but let's see what we can do. So grouping, I always group the components. So mark the symbols in the schematic, go to the PCB layout, hit P, which is the pack and move. So I grabbed the system connector with the ESD diodes. There is the IC with the configuration resistors and the pull-up resistors and the coupling capacitor. These components will be placed most likely close to each other. So again, the second group, place it anywhere. There are two system connectors with some test points, so group them as well. In my opinion, the system connectors should be on the top side, and the load terminals on the right edge of the PCB, just because of my lab. I have the power supply on my right hand side, and I usually place the load on the left hand side of the desk. So I want terminals on the left hand side. It doesn't mean that you have to use the same composition or topology on your desk, but yeah, frankly, I am designing right now the PCB for my usage, so I have to make my life easier, or I want to. Now let's say the second to last group are the filtering components and the shunt resistors. So other group close to the edge of the left edge of the PCB. And now all these terminals, yeah, the remaining four terminals, not a big deal. Naturally, some test points for the shunts, okay, and the mounting holes. Now, my recommendation is to check the PCB layout section of the datasheet, because there are always useful tips and hints how to lay out the PCB. So you can see there is an example of the layout. The shunt, they use I think it's called the Kelvin connection, minimizing the parasitic resistance. So we will use the same routing for the tracks for the inputs as here. The example layout doesn't contain the filtering components, so I will use them somewhere in between the shunts and the IC. There is the decoupling capacitor naturally, and the other other components are missing as well. So what this example tells us is to use this connection of the sensing lines, like the Kelvin connection, and the decoupling capacitor must be as close as possible to the IC. We already know it. Okay, let's get back to the PCB layout and start placing the components. I will start with the terminals, and I have to check. I want to place them as close as possible to each other, to the optimal how to say, distance in between them, because I'm looking for a schematic. Here it is. I'm confused with the split screen. Now I'm checking the data sheet of the terminal, and I'm looking for the drawing of the leads. So 3.5 is the distance in between, and 2.5 millimeter far from the edge. So my center of the PCB of the terminal is in between here. So 3.5 divided by 2 plus 2.5 plus 2.5 plus 3.5 divided by 2. So it means 5 plus 3.5. It means 8.5 is the distance in between our terminals. So this terminal will be 0 on X and 8.5 far from this one. Perfect. Now this one will be placed twice as far as the previous one, and the third one, you name it, 3 times. Okay, now we can place the terminals I always want to place some label in the future, so I will place some space here. Here is from the edge about 3.25 millimeter. Is it far enough? I think it is. And for the sake of clarity, I will place the mounting hole as well. And I can see that in the version of KiCad 905, they corrected the grabbing option for the components where are not aligned with the grid, and in the current version 906 it's again not working. Why to make life of the engineers easier? Okay, now we have to check whether, yes, the grid on the component marks the entry points of the terminals, so we are placing them correctly. Now the channel 1, these two are for channel 1, VBus 1, and these two for VBus 2. So VBus 1 will be placed here with its TVS, and the other one will be placed next to them, next to the previous one. And as you remember, 8.5 will be the distance, but not point, but from the item, from this item. Now I can place the other TVS symmetrically to the same distance, at the same distance from the terminal as the previous one. And now I'm checking the distance from the edge. 2.6. This is not enough. I want to place it about 3.25 as for the terminals on the right side, on the left hand side for these ones. Okay, I think we can use it like this. Now let's continue with the shunt resistors, because I don't want, if this space, this area is large enough for all these components, so I might be too optimistic. So something like this. The filtering components will be somewhere. No, not all the filtering components. The rest, the serial resistors will be somewhere along the way. We can place the component, the package of the IC just to the center of the projected PCB, PCB, and the input for the VBus 1 or the sensing, for the shunt sensing signals is A1B1. So A1B1, and the other ones are C1D1. C1D1. Okay, so on the left edge of the device. So let's say that this IC will be placed somewhere here, like you can see the thin hair wires of the cursor, and yeah, you can see that. Give me a second, I have a call from the UPS. I am here, but I have to go for some components from the UPS courier. So please give me a sec. In the meantime, please, if you like my work, please check this, my new tutorial on Federal platform, KiCad for makers. You can design this beautiful board. I'm here in like 2 minutes. Thank you. I'm back with the box, and you know what? We can make an online unboxing. Can you see the box? Yeah, now you can see my hands, but I will do my best to allow you to see it. Not so easy, but I will manage to do it. Some connectors from GCT. I have to change. Let me. Yeah, it's a pure improvisation, so you can see that I am. Yeah, I'm not able to change the focus, not focus, the focal length of the camera. So there are some goodies from the GCT. GCT is my favorite connector manufacturer. Their technical support is phenomenal. So there are some connector and cable samples. I'm really sorry that you can't see it. Probably if I remove the, yeah, it is the I think you can't see anything because the camera is trying to focus on the center and the center is nowhere. Anyway, I tried and it doesn't work as I think it should, but never mind. Let's continue with the component layout because we are running out of time slowly, and I don't want to be too long today. So let me rearrange the camera again. Now, yeah, here is the price for the course and course is here. We have one comment. 𝗗𝗶𝗶𝗃𝗃. Thank you, Hayek. Thank you for watching. No problem. I am happy that you are here. As always, the recording of the stream will be available a few minutes after the live stream finish. When the live stream is concluded, it will be uploaded to the YouTube and on LinkedIn. In my profile, there will be the stream will be recorded and stored as a normal post, so you will find it in my profile. Let's continue with the layout. So I placed the IC in the center of the ideal PCB, and I started to place the components. I placed two resistors, two filtering resistors, and now I placed the capacitor. Ideally, I think it can be placed closer to IC, but I need some space in between the package and the IC for the manufacturing. There is 2.5 millimeter far from each other. The distance is 2.5. I think no problem at all. So now these 4 components I will use the same symmetry, the same composition as for the 𝗲𝗏𝗀1. Okay. Here are our components for the IC. So we will start with the decoupling capacitor. That must be close, must be placed near the A4 pad of the IC. A4 is here. So something like this. As I said, I want some space in between the packages to convenient manufacturing. The I2C resistors can be placed near the connector, and the other as well as the alert resistor, alert pull-up resistor. What I want to place somewhere in between are these two configuration resistors for addresses. And as you can see, the address inputs are here. So I will place them below the IC. So ideally, these two resistors and the other one, other group. Something like this. Yeah. The thing is that we will need to route in between the pads. So we will have to check the minimal track thicknesses and minimal clearance of Isler manufacturing, because this will be challenging to fan out the center pads, and we need to route. Yeah, this one will be the most challenging, C3, because the distance in between D2 and D3 or D3 and D4 is closer than the distance in between here. This one can be routed with the connected with the A4, and there is 1.4142 times higher distance, because it's a diagonal of this triangle. So something like this, nicely below the IC, with some space for the labels, etc. Now the system connector will be placed again near the edge, and instead of the system connector, I will place the mounting holes first. And you know what? I like the shape 50 to 50 or 50 to 55 maybe. Yeah, I think this is good. We made a good job. I need to see the layers here. Yeah. At the end, I will have to redraw or replace these lines with a rectangle, because otherwise I wouldn't be able to use the chamfer function. But before I do it, I can place the mounting hole anyway. A small trick. We know that the horizontal distance is 50 and the vertical size is 54.5. I will make this point as my 0, delete the lines and draw a new rectangle. Yeah, we couldn't see the the size of the rectangle, but I'm pretty sure we are correct. Yes, we are. So now we can continue with the system connector, and we can grab it by the center pin and place it in the center of the right edge of the PCB. There will be enough space for labels and enough space for ESD protection components we are going to place right now. I recommend to place them in the same direction, so it means it doesn't matter they are symmetrical, because this diode is bidirectional. It's always better to place them in the same direction. It means the cathode, the pin number 2 now, all the cathodes are facing the same PCB edge, like going upwards or downwards. Why? Or left or right? Why? Because the pick and place machine will do a faster job, and the manufacturing representative will love you. The package here is 0402, which is not the genuine package of these diodes, but you can imagine that there is a line on the package marking the cathode side, and we placed all pet number 2 in the same direction, in the same manner. Now these 3 resistors for the I2C, I don't know, something like this. Or we can place them like here, like this, with the line going in between. Yeah, why not? Being creative is always helpful. Yeah, do you know what we forgot to place? The logo of 𝗏𝗏𝗀 Devices. How could I forget? Understand? Do you understand? I don't. I just don't. Yeah, the logo is now stuck to my cursor and somewhere here. We have more components to be placed. Test points. Test point 5 is 𝗲𝗏𝗀1. Test point 6 is 𝗲𝗏𝗀2. test point 7, ground, nicely in between. It plays a beautiful music. I love it. TP8 is a TS. Test point. Now we have 4 more for the shunt resistors. I will place them on the side of the shunt resistor. Because I suppose there will be space for the description for the labels. And my recommendation is to always count with the future of the placement of the labels, because it saves you time. When you trying to imagine, trying to visualize where the labels will be placed, it saves you time when placing components, because when you don't plan the space for it, you sometimes have to rearrange the components and change the PCB layout, which is a rework. When you try to imagine, yeah, let's say that there will be a logo of many devices. There will be above will be the name of the board. There will be space for the labels for the system connector. There will be labels for the terminals, for the loads. There will be labels for the VBus1, VBus2. So yeah, if I place some random component here, it will disrupt the nice space for the logo. Yeah, of course, this PCB is simple. This PCB contains like 20 components. It's not a big deal. But when you will work on a much complex device, you will understand. So now I am going to make a fillet, and 4.5 is the correct fillet parameter. Our PCB looks like this. Yeah, there are no labels, no tracks. We are ready to start. So we have two options. Option number 1, which I think is the better one, is that I will set up the board. I will configure the board setup for this and conclude the live stream, and I will continue with the PCB layout next week, because we have plenty of time, and I think that I will not have enough time today for finishing the PCB layout. So in my opinion, it's better to start the entire job next week. Let's config the board setup. We will use the two-side layout with the ANIC board finish. Solder mask expansion will be 0.07. Constraints. We will keep the default via size, copper to edge 0.5, minimum through hole 0.3, because our, as you will see, via size is 0.6, is the outer diameter, and drilling is 0.3. This is perfectly our minimum through hole. Minimum height thickness will be 0.7, just to be safe. For the DRC, predefined sizes 0.3 is my absolutely favorite, like normal thickness of the line. 0.5, 1 and 2. And vias, I usually add a 0.45/0.25 millimeter via, but we will not need it this time because the design is simple. What we have to config is the net class, because as I mentioned, the IC is quite fine pitch, and we have to check the capabilities of the Ēsler manufacturing. Technical capabilities. We have 2-layer 1.6 and here are their design rules. We are looking for the minimal thickness of the wire, of the track, and the minimal clearance. So here is minimum trace width is 8 mil. It means 0.2 millimeter, and minimum clearance is 0.15 millimeter. I think it will be not enough for this. It means that we will not be able to fan out the inner pads. That's bad. That's very bad. Yeah. See? Not good. That's not good. Let's check the capability of 4-layer one. There can be some better values because the 4-layer one is for high density or higher density designs. No, but let's check. Yes, the minimum trace width is 0.125. Let's edit it just for the sake of the check. So minimum track is 1.25 and the minimum clearance is the same. I don't know if it will be enough. No. For this one, yes, the enable can be connected, but the C3, which is the, I think, address line, C3, yes, A1. We have to check what is the default state of the A1 if we can left it floating. It's not ideal, but we don't want to order high density designs for the testing of this INA2227. That wouldn't make any sense. So we have to check what is the address default state and if we can left it floating. A1 or A2. Connect to ground, so yes. Just by this sentence, we are instructed that we can't left it floating. What can we do? I have an idea. As you can see, we have three options. Yeah, three options. You can see we can directly connect it to ground because I can route this. We can connect it to SCL. and we can connect it to the SDA. It means that the address 1 pin wouldn't be configurable, but will be like firmly connected to the, and I think ground is the best, like 0 is the best option. So if you understand, if you agree, and I believe you will, I will change the design that the A1 will not use the configuration resistors, but it will be connected firmly to ground. It's the clearest solution, because otherwise the PCB is not routable. There is no enough space for fan-outing this C3 pad. Yeah, not enough room. So here is the schematic editor, and A1 is the trouble. So I am deleting the configuration resistors and connecting it firmly to the ground. It means that I can connect this here, and the other address bit can be configurable. Yes, and now it says that I was not correct, because for the shortly there are 4 options. Each address bit can be connected to ground. Yes, that's what we currently support, but as well as SDA and SCL. So SA, let's say, like to get something in return, that we just limited the features of the tool. We can use 2 more resistors marked as not populated, connected with the other 2 signals, and the other 2 signals are SCL and SDA. Can we place the resistor in here? Yeah, we can. Is it better? I think it is. I think it's a good compromise. Something like this. Let's continue with the board setup. We change the setup to 4-layer, like this. The same finish, the same expansion, the same constraints. What we changed is the track width and the default clearance here in the net classes. So basically, we are ready for the PCB layout job. Can you see how small this BGA package is? Yeah, the board is huge for it, but it's a testing board. I started routing. I changed my mind. I will do my best, and we will see what I will be able to do today. Let's check the layout again. Do they use routes only, or tracks only, or polygons? They use tracks only. I am not going to connect the ground pads because they are connected firmly to the inner layers, which is something I'm going to do now. So the polygon for the copper layers, I don't know the hotkey, so I have to call it from the menu. Thermal reliefs, minimum clearance can be 0.2. And I will change the connection to solid because the inner layers should be connected with the solid connection. The copper pore of the inner layers should be set as solid. Yes. So now we have all ground points connected with the ground pads connected with the via are directly connected with the inner layers. Yeah, there is as you can see, there is an issue with not an issue, it's normal. The IC is above the shunt resistor, so the wires, the tracks are crossed, so we have to use a via. It shouldn't be a big deal. Like it's not beautiful. The via is definitely not something that I like, but this is how it is. We have to work and play with the cards we have on the table or in our hands. Yeah, I made a mistake. I think no. I will keep it. I will use the thinner tracks will be the minimal possible. I'm routing these SDA and SCL lines a little bit further from the coupling capacitors because I have to, and I want to place two symmetrical vias for the address config resistors. I don't like this test point here. Much better place will be here because here will be in line with the other ones, and I will have space for this track. Part of our testing can be to verify if the vias on the signal lines have some negative influence to the function of the monitor. I don't think it will, but we will definitely check it. I will use the vias instead of the top layer tracks, because I won't. Because I want to, and I will use the thicker tracks because this design is somehow special, and I want to use the thick track as much as possible. I will place a via here. You know what? No, I will keep it. It's not beautiful, it's not nice, it's not something I am proud of, but I will keep this line here because I don't want to route any track below the IC, despite the fact that there are two inner layers with reference plane. I will keep it like this. Yeah. I will not use this reference designators because instead of them there will be text labels with a proper description. Here can be our reference designators. I'm changing the size of this label to be of the same size as the other ones because it looks better. And now the labels. So 𝗲𝗏𝗀1 here.
For unlimited listening, head over to brain.fm or follow
No.
the description below.
No. Do you know what? Do you know why? Because there will be a different label. There will be load, light load, high load. I changed the label instead of. I can make a trick. Copy, undo, paste. I want a small gap in between the labels. I like it this way. So here is the high side load. Yeah, I said high load, but I meant high side load. So high side. Channel 1 or no, it will be below. It will be below. I think I will manage to do that. If not, I will have to change my plan or to move the terminals further from the PCB edge, which is not something I would like to do, for obvious reasons. You know what? I will use something like this on the side, marking the meaning of the terminals. Now the system connector and configuration registers. I like the shape of the arrow, which is like self-explanatory. GND, SCL, SDA, and alert, which alert. Test points. I want to create smaller. Oh, It's a minimal size. Okay. What's the size of the 0603 resistor? That's 0.6, am I right? I think 0.6 can be a pitch, yeah, spacing. No, it is not. 1.5. I might be correct with the size of the 0603, but there is a gap in between them. I noticed that we have a comment, so I'm going to get to you, author of the comment, ASAP. Let me finish these labels. Good afternoon, Julio. What measures of track you use? The thinnest and thickest. Yes, I spent some time explaining that for this, literally for these two tracks, I had to go to the thinnest thickness, which is 0.125 millimeter with the same clearance, and the thickest is 1 millimeter here. I don't know if I keep all these tracks to be as thin, but I think I can use it. I haven't used such thin tracks on the entire layout, so it can be interesting how the manufacturing will be successful. I think there is still quite a headroom for the manufacturer because their capabilities are much higher. So yes, 0.125, the same for the thickness and clearance, and 1.0 are these lines. These 𝗲𝗏 lines can be thicker, 2 millimeters, as I defined in the setup. So yeah, thank you for asking. I changed them. So this is how the PCB look like. 𝗲𝗏1, 𝗲𝗏2, high side, low side, loose side system, connector, blah, blah, blah. Everything is there where it should be. We have to only mark the pin number 1. There is a corner, but still there is nothing that can beat the filled circle mark. Like this. That's time for design rules checker. But before, I have to recheck the. Thank you for the comment, Julio. I have to check the constraints because we changed the minimal. I think here as well here. Yes, to avoid some extra findings. 0, 0, unconnected 0, we are good. So despite the fact I planned to finish or to start on the PCB layout next week, I will finish it, but there is still missing the name of the board, which is INA2227 V01. Yes, with slash and slash. and the size will be much bigger. Let's try 3 millimeters. Yeah, not bad, not bad. Our cat can go, no, it's nice, but too big, 2.5. Yes. I'm aligning the bottom edge of these labels while moving it a little bit farther from this via because we don't want to overlap the silk screen with the via. Yeah, I think a little bit further. Yeah, like this, because we have to count with the solder mask opening. Okay, so this is our render. Looks good. I will keep it for the sake of the conclusion of the stream, and I want to call DRC again. No issues. Okay. So this is it. We are done for today. Thank you for watching. Thank you for comments. This is our new board with the INA2227, the energy monitor, 2 channels. Yeah, I am tired and I have to conclude the session. Thank you. See you next week. We will be probably, most likely design the 4 to 20 milliamp current loop receiver, the isolated one. I have to check some a design block I used for a design, but I didn't use it fine at the end, and I want to check this block. So a discrete 4 to 20 milliamp current loop receiver, optocoupler, 2 op amps, BJT, Zener diode, a couple of resistors, capacitors, I don't know. This will be next week. See you next week. Bye.